Okay, so this is one of the most easy way to see the glycogen synthesis in a flowchart form. So glucose is converted into glucose 6-phosphate, into glucose 1-phosphate, into UDP glucose, and back into glycogen. Okay, and this glycogen, once it is broken, it will be first converted into glucose 1-phosphate, then into glucose 6-phosphate, and into glucose. And obviously there is a minor metabolic pathway which will break down this glycogen directly into glucose. So these are the pathway. So how it is regulated? There are two ways it is regulated. First, based on the energy or the substrate signals. So what are the energy or the substrate signals? Glucose or ATP AMP level. Okay, glucose or ATP AMP level are major energy or substrate signals. The second regulation is based on the hormonal. There are three very important hormones which decide whether the glycogen will be broken or glycogen will be synthesized. These hormones are glucagon, insulin, and epinephrine. We'll look at each of these regulations one by one. So let's look at the substrate regulation first, or energy signal regulation first. So remember, glucose 6-phosphate and glucose and ATP, all these things inhibit glycogen phosphorylase. So when there is a high level of ATP, glycogen phosphorylase will be inhibited because the cell already has ATP. Whenever there will be high level of glucose, glycogen phosphorylase, that is breakdown of glycogen, will be inhibited. Whenever there is high amount of glucose 6-phosphate, again glycogen breakdown will be inhibited, because ultimately glycogen phosphorylase will convert the glycogen into glucose 6-phosphate, and already there is a high level of glucose 6-phosphate. Whereas glycogen synthesis will be determined by only glucose 6-phosphate level. This is very interesting, because we are going to see a disease where the glucose level is low, glucose 6-phosphate is high. Okay, so because the glucose level is low, ideally the glycogen should be broken. But in that case, because the body does not consider glucose levels, it simply considers glucose 6-phosphate level for glycogen synthesis. So in that case, what happens? Because glucose 6-phosphate level is high, it will stimulate glycogen synthesis, and more amount of glycogen will be formed. Whereas logically, more amount of glycogen should be broken in that case. But even though glucose 6-phosphate level is high and glucose level is low, glycogen synthesis will happen. So this is very interesting. We'll look at this glycogen storage disorder in a while. So this was the energy signals. Let's look at the hormonal signals. The first two hormones which regulate the glycogen metabolism is glucagon and epinephrine. Now, one important difference between glucagon and epinephrine is glucagon has receptors only in liver, and it makes sense also. Glucagon, the primary function of glucagon is to bring up glucose level, and we know that only the glycogen which is stored in the liver will be converted completely into glucose and bring up the glucose level in the circulation. Whereas epinephrine, okay, has receptors both in muscle and liver, because epinephrine is your fight and flight hormone. Okay, so your muscle has to be ready, so the amount of glucose in the muscle should also increase. Otherwise, the mechanism of action of both glucagon and epinephrine is same. The only difference between glucagon and epinephrine is that glucagon has receptors only in the liver, whereas epinephrine has receptors both in the liver as well as muscle. So what do both of these do? They will first activate G protein, which will activate adenyl cyclase, which will convert ATP into cyclic AMP. This is your secondary messenger. This will activate the protein kinase A, and this protein kinase A, they will phosphorylate all the enzymes. Okay, and once glycogen phosphorylase is phosphorylated, it becomes active, and once glycogen synthase is phosphorylated, it becomes inactive. So what will happen? Whenever glucagon and epinephrine is there, glycogen breakdown will happen and glycogen synthesis will be inhibited. Okay, so this is how glucagon and epinephrine regulate the breakdown of glycogen. The next is a very important mechanism which exists only in muscle. Okay, now muscle has to break down glycogen when the muscle is contracting, and it has nothing to do with the glucose level. So how does muscle achieves it? So there is a cyclic AMP independent pathway in muscle, and this pathway is basically called as calcium calmodulin sensitive phosphorylase kinase. So ultimately they will activate the phosphorylase, and both of these will be phosphorylated, and this will become active and this will be inactive. But the phosphorylation of both these enzymes is not by cyclic AMP. Basically, in muscles we have a calcium calmodulin sensitive phosphorylase kinase. And what this does is, whenever the muscle is contracting, the calcium will come inside the muscle cell, and then this phosphorylase kinase will be activated, and what it will do, it will phosphorylate both these. It will get activated and it will become inactivated. So this is a cyclic AMP independent pathway. We saw, when we saw in the both glucagon and epinephrine, cyclic AMP was very important as a secondary messenger for phosphorylation of these enzymes. But in this case, it is a cyclic AMP independent pathway. So what happens, this calcium and cadmodulin sensitive phosphorylase kinase will activate muscle activate the muscle phosphorylases, and what it will do, it will phosphorylate this, it will phosphorylate this will become active and this will become inactive. So this is how the glycogen breakdown is regulated, especially in the muscle cell, because muscle has to coordinate the glycogen breakdown with your muscle exercise. Next, let's look at the how the glycogen metabolism is regulated by insulin. So by insulin, it is regulated in two ways. First, insulin directly activates phosphatases. So what does phosphatase do? It will dephosphorylate both the enzymes. The moment this is dephosphorylated, it will become inactive, and the moment this is dephosphorylated, it will become active. Okay, so this is the first mechanism. The second mechanism is insulin also activates phosphodiesterase. So first enzyme it will activate is phosphatase, which will remove phosphate. Phosphatase is remove phosphate. Okay. The second enzyme it will do activate is phosphodiesterase. What does this phosphodiesterase do? It will convert cyclic AMP to 5-AMP. And so what will happen? There will be a decreased in cyclic AMP level, and this cyclic AMP was what was activating protein kinase A, leading to the phosphorylation of these enzymes, okay, leading to the glycogen breakdown. So with decrease in cyclic AMP, phosphorylation of these two enzymes will be inhibited. So on one side, the phosphorylation is inhibited, and on the other hand, whatever phosphate was added is removed. So what will happen as an effect? Glycogen synthesis will happen, but glycogen breakdown will be inhibited. So this is how the glycogen breakdown is managed, or glycogen synthesis is managed with various different hormones. Now, having learned about all these mechanism of glycogen regulation, like what is helping in synthesis of glycogen and how the glycogen is broken down, let's now look at various glycogen storage disorders.